Okay, so our first speaker today is Pat Barry. Pat Barry is Chief Executive Officer of the Irish Green Building Council, which he co-founded in 2010. He's an architect with over 20 years' experience in Ireland, Europe and South America, and has a Master's in Environmental Design of Buildings from the University of Cardiff, and is a qualified Passive House and DGNB consultant, which is the German Sustainability Council. So that's Pat to the floor.
Good morning. Thanks for the invitation. I suppose what I'm going to talk about is embodied carbon, environmental product declarations and circularity. So I suppose the key thing the key issue here is about resources and the resource crisis. I always start with this diagram because it illustrates our challenge over the next 20 years of an increasing population and diminishing resources. One of the problems with the way that we look at the transition to climate change is that we tend to look at it in silos, and this is the way government tends to look at climate change. It looks at decarbonising transport, electricity, buildings and industrial, and it looks at all of those in complete isolation. So the answer to transport is, why don't we just swap out our petrol and diesel cars with 1 million electric cars? Or why don't we just put in 400,000 electric heat pumps? Of course, that doesn't really work because all of these things are interconnected. If you swap out 1 million electric cars, all you do is you need all of the resources to manufacture those cars. You need to store all of those cars. You need to construct infrastructure to store those cars in underground car parks, in surface parking. So if you're going to make a resource-efficient transition, you have to look at how all of these things are connected. So if you were to look at a transition where you say, no, we're going to halve the number of cars, then that opens all of those other possibilities to create better density, to reduce transport emissions, to reduce industrial emissions from avoided construction. If you look at things like water efficiency in buildings, then you have the possibility to reduce the amount of water infrastructure that you have to construct. So by looking at these things in the round and looking at the connections, you can move far faster to transition to a lower carbon economy. And I suppose this is what we're really talking about. Carbon emissions don't just come from the operation of buildings, they come from the mining and quarrying of materials, the transport of those materials to our manufacturing plants, the manufacturing process itself, the transport to our sites, the integration of those materials into the building. So it goes on, the impacts are far more than what we typically think of building. Then of course we've got the location, we have to transport people between buildings. And finally, we have demolition. So in terms of what embodied carbon is, embodied carbon are the carbon emissions associated with the materials and construction processes throughout the whole life cycle of the building or infrastructure. Now, buildings are responsible for 39% of carbon emissions, 28% of those are from the operation of the building and infrastructure, and 11% of those global emissions are from what's called all of the other activities associated with the construction and manufacture of products. So, in order to meet our climate commitments, we've signed up to COP21 in Paris. We're not going to meet those by getting to net zero operational emissions. We have to get to net zero operational emissions and net zero embodied emissions. So that needs a complete transformation in the way that we actually construct. And I'd point out this report from the World Green Building Council that was released last September. It sets out two targets. It sets out the definitions for net zero embodied carbon. But it also sets out two targets by 2030. And we're trying to get these two targets into all procurement practice from now on. By 2030, all new buildings, infrastructure and renovations will have 40% less embodied carbon, with significant upfront carbon reduction, and all new buildings will operate to net zero operational carbon. And when we talk about net zero operational carbon, we're also talking about all of the plug loads. When we talk about operational carbon, typically in Ireland, we're just talking about the regulated carbon. Full net zero carbon, we're talking about all of the equipment you bring into the building as well. By 2050, the second target, by 2050, all new buildings and existing buildings will operate at net zero carbon. And of course, all new buildings do. So you can download that report from our website. Now, how are we going to actually get to this point? Nobody's really doing any measurement at the moment. We're all familiar with the BER, but nobody's really looking at embodied carbon. And this is starting to become a bit more real now. The European Union has brought out, DG Environment has brought out a set of indicators for circularity and life cycle assessment of buildings called levels. And we'll be working on trying to mainstream that over the next 3 years through the levels, this Levels project. You can download this manual from DG Environment website. But this sets out a set of detailed indicators that should be applied for reporting on construction, new construction. And just to give you an idea of what's in it, it's looking at, this is one thematic area on life cycle environmental performance. So it's looking at life cycle assessment, life cycle costing, water consumption, waste reduction and circularity. And the intent is that this should be integrated into public procurement and eventually into building regulations over the next number of years. So it's starting to become a little bit more real in that it's moving from people talking about embodied carbon and circularity, it's moving towards what could potentially in the next 5 to 10 years be an environmental performance of buildings directive, much like the energy performance of building directive. Now, there's two standards for life cycle assessment that you should be aware of. The first one is at the product level. EN 15804 sets out how the life cycle of a product should be declared through environmental product declarations. And then at the building level, we have EN 15978, which sets out how this, the life cycle assessment for a building should be carried out. And just to go into, so what we're talking about with at the building level, what you are doing is you're aggregating the total impact of the building is the total quantity of materials multiplied by the impact of the materials at every life stage. So EN 15978 is very much about aggregating all of the impacts of the components that go into the building, plus the operation of the building, and finally the disposal of the building. So this is what a full life cycle assessment looked like, and those two standards set out a common set of modules that you report against each one of these modules throughout the life cycle of the building. Sorry, I'm going a bit too fast. So, for example, at the raw material stage, at the manufacturing stage is A3, there's A1, A2, A3. A4 is the transport of the materials to the site, the assembly on site. the use, maintenance, and repair of the building throughout its lifetime. So certain design decisions will require, say you put a flat roof on a building, a flat roof will tend not to last as long, say, as maybe a pitched or a slate roof. So you have to account for the number of times you need to replace that flat roof over the lifetime of the building. And typically the lifetime of the building is taken at 60 years. So say the flat roof lasts 15 to 20 years, then you must allow for the fact that you will have to replace that twice over the lifetime of the building, and you have to account for the embodied impacts of replacing it twice. So this is how it sets out all the modules in a typical life cycle assessment, from A1 all the way to D, which is, this managed to crash the, press the wrong button there. No, it's back. So what we're looking at is a full cradle to cradle. So at D, we're looking at what the potential reuse or future life of that product is. Now, just to be aware, we have a platform called WWE PD Ireland, where you can download environmental product declarations, so you can find out data on different products. I think we've about 120 products up there, every type of insulation, every type of we've quite a lot of roof materials, finished materials, insulations, some precast materials such as blocks, well, certain types of blocks. But we also have a program whereby Irish manufacturers can develop environmental product declarations for the products. So this is how you can search on the website and find an environmental product. You can find data on the different products. And we have published through our own program to date about 12, 15 EPDs for about 65 products. And we have a whole series of environmental products coming through at the moment, even from smaller manufacturers. I'm afraid I put this on slideshow and now it's going mad on me. But just going back to there is interest now from Irish manufacturers in producing the data. Now, why do we need this data? If we're going to actually calculate the full life cycle of the building, then we need the product level data to do that. So we have all of these companies have already committed to asking for environmental product declarations, and that's the first thing that we need. We need data, and we need a commitment to look for that data. Now, when we're developing LCA at the building level, this is from the Royal Green Building Council report. It was really essential to start looking at the life cycle of a building at the very early stages, before you even pick the site, because the biggest benefits come from seeing if you can avoid building anything at all. I mean, if you can avoid building a building, then you have zero impact. And quite often, if we look carefully at the brief and our needs, we can actually design out the need for that building. But most of the key decisions that we make on life cycle assessment are made in the early stages of concept design. If you're familiar with the RIAI stages 1 to 4 are the most critical stage. And generally, it's only the architect who is involved in that stage. Sustainability consultant quite often comes in a bit later. And generally what they tell us is that by then, it's too late to do anything significant to reduce the embodied carbon. And the further you go on in the process, the less impact you can have. So it's really vital that we start to put tools in the hands of the architect at concept stage to reduce the embodied impact. This diagram here from One Click LCA gives you an indication of where the biggest impacts are in designing out carbon, embodied carbon. So if you can avoid building anything, you're 100%. If you've got soft or poor quality ground, you can end up spending 40% of the entire upfront carbon in the foundations. You know, if you have to do deep piling. So there's lots of ways that we can make optimizations without going near even low embodied carbon. Even low embodied carbon materials do have a big impact. There's all of these other things that are to do with structural design, architectural design, that can have as much or greater an impact. That's why we're trying at the moment to get tools into the hands of architects at concept stage, whereby they can do a SketchUp model and they can import the data into a simple tool like this and do iterative design and do a comparative assessment very early on. And we think it's critical that this gets into the hands of planners as well, a planning stage, that an architect, if he's going in for planning for a home or for an office, can do a quick assessment in half an hour, and actually produce a report for the planning authorities. This is the environmental impact. This is the full life cycle carbon impact of putting this building here. And I actually have a figure. If there's any funders in the audience, for 30,000, I can deliver this tool free to everybody in Ireland. So if there's any funders, I'd like to talk to you after. So it's critical that we start looking at the amount of demolition that's happening. This is an example. Building that was demolished, rebuilt, with no real added value, but a huge embodied carbon, upfront embodied carbon impact. That's why it's critical to have tools that are available to planners, whereby the design team has to demonstrate what the environmental benefit of what they're doing actually is. We can eliminate huge amounts of carbon simply by designing out the need for underground car parks, by avoiding unnecessary finishes, having simple demountable finishes that allow the materials to be reused at the end of life, getting rid of extraneous finishes and materials. Circular demountable things like this is an Irish company, Terratonics, who are trying to take over the world with cement-free foundation systems. Simply that can be quickly and easily mounted without the need for concrete. Looking at alternatives to concrete walls, how do we create products like this hemp line block that doesn't contain any contaminants? That at the end of the life, you can simply grind it up, you can spread it on your land. Low carbon cement. This is a company called Carbon Cure, who pump liquefied carbon dioxide into the concrete to cure it. You know, you have DGBS concrete. There's also solutions like this coming onto the market. And this is a product that we've developed in the lab, research that we've developed in the lab using crushed concrete together with a bio binder in lieu of a cement binder. And they're able to actually grow these blocks. It has the strength of a kind of a low-grade block. But coming on to circularity, this is, you know, in terms of our colleagues in the Dutch Green Building Council have developed these indicators. So it's accountability, what I talked about earlier. Can you avoid the need for the building? Can you design it for reassembly? Can you maximize the amount of reused materials, the amount of renewable content to manufacture the materials? And then a critical thing that comes up is the availability of information. I know Dara is going to talk about this shortly, because if you don't know what's in the material, or you don't know what standard it has been developed to, then it's very hard to reuse it, because you don't know whether it meets the current standards. And designing out toxicity in materials is absolutely critical, because if you have toxic materials in a building or in a material, you simply can't reuse it. You can't recycle or reuse it. And that's why the Dutch are leading in all of these areas. If you want to find out what's happening in circularity, the Dutch are really leading the field here. Have a look at this website called Madaster. The whole idea of this is that, we see buildings as material banks. We should record everything that is in our building and hold it for the future so that we know exactly what is in our building, all of the components in the building, what they're made of, what ingredients are in the product, so that we know whether we can use that in the future. And in 20 years' time, when you're doing a refurbishment, you know you can use those tempered glass dividers because you have the data sheet to show you that it is tempered glass. Things like that. You may be familiar with the Home Performance Index. We have set out a number of indicators. For example, the key one is discouraging over-designed homes. We set out net zero carbon definition. We set out targets for embodied carbon. We've set out construction waste targets. And we're currently integrating the whole levels framework into it. So the main thing is to start to become familiar with the targets that are already out there. So it doesn't matter whether you're above the targets or below them, you need to know where the actual target is, what you should be meeting in terms of circularity, embodied carbon and waste. So thank you.